Next up, we have John Kang from University of Rochester, teaching practical data science via an interactive web-based tool.
All right, well, thanks for inviting me to give this talk. I have a subtitle to this title. So, why physicians need to understand models. So, the outline of my talk, I'll discuss a little bit about why I think artificial intelligence needs to be trustworthy, how physicians can help improve this trustworthiness, and how do we teach physicians the fundamentals of how to create trustworthy models. How trustworthy is AI, is the Blackbox AI? I think we see several examples, most notably, I think the most obvious example recently has been the flight disasters of the Boeing 737 MAX 8 models, where I consider this a failure of artificial intelligence. So the AI was created to compensate for hardware design where these planes, because of the engine placement, sometimes the front of the plane will tilt up. And artificial intelligence would try to compensate for that by tilting it down. And that was called the maneuvering characteristic augmentation system. However, the pilots didn't understand what the model, the intelligence was doing. So they try to compensate for that, and you can see that in that bottom plot, the altitude going up and down as the pilots are trying to compensate. And unfortunately, ultimately this led to a crash, one of two crashes, and as a result of the end users not really understanding the model that they were given. So clearly, even though this model probably during the testing phase, when Boeing was piloting their software worked, that does not mean that when it's deployed in the wild that these models are completely trustworthy. So the current draft recommendations of the ECG includes a few additional areas that trainees are expected to have competence or some understanding of. One of them is informatics. So I think an important aspect to discuss is route authentication, preparing physicians for AI-assisted future. And I don't think we can really rely on regulators like the FAA, FDA to police this. I think we have to also take some personal responsibility because the regulators aren't perfect. So there are some physicians, some researchers who feel like if you have a good performing model, that means it's trustworthy. So I just wanted to give an example, go through a case example of why this is necessarily the case. So there were researchers that were interested in predicting survival outcomes from pneumonia. So they created models to do this, several machine learning models. And one of the things that they found was that if you had asthma, that seemed to improve your survival. So the researchers, they're asked their clinician colleagues, well, why does asthma improve your survival from pneumonia? And then the clinician colleagues, they were able to explain that the asthma was not a causative factor for survival, but it was associated with improved access to care, having a pulmonologist, being very aware of the symptoms so that you would be more quickly to go to the emergency room or see your doctor if you develop symptoms of pneumonia. So in this case, if there wasn't this check with physicians, if the group tried to just deploy this out in the wild, people might take this information and then discourage people with asthma from going to seek care because it's associated with a positive survival. So I think this is an instance where physician collaborators, working closely with researchers, can really bring domain knowledge and help untangle some of these confounding effects that are all over, data sets. We can't always predict. We don't always know beforehand what is a confounder and what isn't. So then, how do we engage trainees into being involved in these building of trustworthy models? So this is an active discussion that I've had with several stakeholders, so faculty members who are interested in this. And tentatively, we have a couple of points that we've been discussing. So one is create awareness and proper conduct in AI. So that includes issues of ethics, fairness, inequalities that can arise when we just kind of take AI for its face value. I think that's a good starting point. The keynote for Astro next year, one of the keynote speakers is a medical ethicist. It's a co-keynote with artificial intelligence researchers. So I think that the medical field is well aware that there's a lot of ethical issues in AI, and we're trying to work within that realm as well. Second thing is to implement a practical curriculum to basically teach people who are interested in this. Third is to create a public resources. That's something that's very common in the computer science space in general. There's a lot of open access, freely available resources. And fourthly, generate accelerated learning and funding opportunities. So accelerated learning is a common method in other fields like medical oncology, for example. There's several workshops that ASCO AACR they hold, and people go to these workshops for like a week. They get a really intense education experience. And then funding opportunities goes without saying. There's certainly, and I'm interested in this area, artificial intelligence, radiation oncology, but I think as a group, trying to find these opportunities and give them to our trainees is important. So I'll talk a little bit about some of the ideas that I've had for implementing a practical curriculum and then creating a public resources. And I think a great example, we can give thanks to Erin Gillespie and her UCSD team in terms of creating a great open source educational tool. So eContour, I think most trainees, if not every trainee, has definitely used this. It's certainly much better than a few slices on a manuscript in terms of contouring. And I think there's a couple of, I'm no med-ed expert, but I think certainly a few aspects of learning come through in something like eContour. So you have verbal learning, kinesthetic learning, so kind of like moving with your hands. I know Dr. Gillespie is working on additional live contouring experiences as well, where you can actually contour in eContour, and then visual spatial learning. So I think we can adopt these similar concepts to teaching clinicians, busy clinicians who have a lot of competing responsibilities, but we can rely on these straightforward learning methods. So we want to basically combine something that has verbal learning, kinesthetic learning, working with your hands, and then visual spatial learning. So the computer science community has given us a really interesting tool called Jupyter Notebooks. Okay, so just really briefly, there's verbal learning, there's kinesthetic learning, and there's visual spatial learning. So you can combine word processing, text here, and then you have some code that you can edit live, and then you can run that code so you can get some nice visual spatial representation. It runs in a web browser, and there's a link there that if you click it, it should go to this notebook. If you're interested, it's talking about how to create a model for screening like breast cancer. So thank you for your attention. And I think one of the aspects of basically trying to teach data science to clinicians is really asking the group, how do you plan on gauging the trustworthiness of a model, especially a model where it's trying to do clinical prediction, not just, for example, auto-segmentation, and you don't have a perfect way to check whether that's, you can't just check it right then and there whether it's a good model or not. Thank you for your attention.